Hello friends, welcome to this lecture series of class 11th mathematics. So in this lecture series I'll be posting videos where I'll try to cover the topics of HSC board class 11th mathematics. So in that series the first topic that we are going to start with is angle and its measurements. Okay, so what do we have in this angle and its measurements chapter? Let's have a look. Starting with an angle. So for an angle, what do we require is two arms or rays with a common vertex point, So as we can, common vertex point. So as we can see over here on the left hand side diagram over here, we have two arms, arm OA and arm OB, where we have a common vertex point O. The starting arm is called as the initial arm, and the final position of the initial arm after rotation is called as the terminal arm. Now, when we talk about angles, the sense of rotation of angle is also important, which can be seen from the two figures as shown, figure number 1 and figure number 2. Let me just clear out this mess over here. Okay, fine. So in figure number 1, the initial arm is OA and it is rotating in an anti-clockwise direction to reach the position OB. On the right hand side in diagram number 2, we have OB as the initial arm, which is rotating in the clockwise direction to reach the final position of the terminal arm OA. So we have two sense of rotation, a clockwise rotation and an anti-clockwise rotation. Generally, the clockwise rotation is considered to be negative. So the clockwise rotation for the initial arm is considered as a negative angle, and the anti-clockwise rotation is considered to be positive. So the clockwise rotation for the arm of an angle is considered to be negative, and the anti-clockwise rotation for the arm of the angle is considered to be positive. Okay. Now, moving on towards some types of angles. So the first type that we are going to study is a zero angle. So what is a zero angle? It is an angle in which the initial arm itself is the terminal arm. So let me just draw this and show you. So if we have an angle where the common vertex is O, and this is the initial arm. So this position is OA. The final arm lies on the initial arm itself, like this. Okay, so this is the zero angle. Where the initial arm coincides with the terminal arm. Then we have one rotation angle. So we are done with zero angle. Now we are going to have a look at one rotation angle. So what is one rotation angle? So in one rotation angle, the initial arm of the angle undergoes one complete rotation about the vertex. So let's have a look. So when we draw a one rotation angle, it looks similar to that of the zero angle. But what is the difference? In zero angle, there is no rotation. But in one rotation angle, let me just clear this out. Okay. In zero angle, there is no rotation, but in one rotation angle, the initial arm has undergone a complete rotation and reached the initial position again. So in zero angle, the coincidence of the initial arm and the final arm is because there is no rotation, and in one rotation angle, there is one complete rotation. So one rotation angle, rotation is there. Okay, now after one rotation angle we have a straight angle. So in this straight angle, what do we have? The initial arm and the terminal arm both lie in opposite directions. So initial arm and terminal arm both lie in opposite directions. So how do we show that? Let's have a look. So if this is the common point vertex O, and if this is the initial arm in the right hand side direction, the terminal arm or the final arm will be in the opposite direction. Okay, so this is called as a straight angle. So this is the rotation, an anti-clockwise sense of rotation from OA to OB. Then we have a right angle. So what is right angle? It is 1/4 of one rotation angle, which means you have to take one rotation angle and divide it into 4 parts. That 1/4 part of the one rotation angle is called as right angle. And how does it look? If this is the initial arm with the common vertex O, the final arm is like this. Now we know this angle, right angle, since our childhood, because we have learned Pythagoras theorem, and we denote it like this. And we also know that the angle major is 90 degree. So what is this 90 degree? We'll see in the measurement of angles. Okay, fine. But since our childhood, we know that right angle is nothing but an angle which measures 90 degree. Okay, fine. Now, angle in a standard position. So what is an angle in a standard position? So when we talk about angles in a standard position, we are actually talking about angles in a rectangular coordinate system. So what is a rectangular coordinate system? The 4-quadrant system. So this is your y-axis, and this is your x-axis. Fine. This is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. Okay, so when we talk about angle in a standard position, we talk about this rectangular coordinate system. And in that rectangular coordinate system, for an angle in a standard position, the vertex should always be at the origin, and the initial ray should be along the positive x-axis. So this origin becomes your vertex, and this positive x-axis becomes your initial arm. So where should the final arm be? The final arm can be anywhere in any of the quadrants. It can be over here like this, it can be over here like this, it can be also over here like this, it can be anywhere in any of the quadrants. So what are the rotations? How are the rotations? This is the first rotation, this is the rotation for the second angle, and this is the rotation for the third angle. Okay, the general sense of rotation is taken in anti-clockwise direction for all the angles. Why? Because we consider it to be positive. Okay, chalo. So that was angle in a standard position. So till now what we have seen? We have seen a zero angle where there is no rotation. We have seen one rotation angle where there is one complete rotation of the initial arm to reach the same initial position. And in both the zero angle and one rotation angle, the initial arm coincides with the terminal arm. Then we have a straight angle where the initial arm and the terminal arm both are in opposite directions. And then we have the right angle, which is by definition the 1/4 part of the 1/4 of one rotation angle. After that, we saw angle in a standard position, for which we require a rectangular coordinate system in which the origin becomes the vertex of the angle and the positive x-axis is the initial arm of the angle. Chalo. Then we have quadrantal angles. Now what is this quadrantal angle? Again, we'll have to look at the rectangular coordinate system. So again, we have this rectangular coordinate system. So quadrantal angle is a subtype of angle in a standard position. So in a quadrantal angle, the origin again is a vertex point. The positive x-axis becomes the initial arm, and the final arm can lie only on the x-axis or y-axis. So which are the available positions for the final arm? So this position is an available position for the final arm. I'll take the black color. So you can have the final arm like this, B, or the final arm on positive y-axis like this, B dash, or the final arm like this on negative x-axis, and the final arm like this on the negative y-axis. So these are the possible positions for the terminal arm or the final arm, where the final arm can be on the positive x-axis, positive y-axis, negative x-axis, or negative y-axis. So let us have a look at the definition now. So what are the quadrantal angles? It is an angle in the standard position with its terminal ray lying along x-axis or y-axis. It can be positive or negative x-axis, similarly positive or negative y-axis. Then we have coterminal angles. Now coterminal angles are nothing but it is a terminology we use when we are comparing two angles. And which are these two angles? These angles, the initial arm and the terminal arm, they coincide with each other. But how they are different? Because the rotations for them is different. Now let us have a look at an example. So now I'm drawing an angle over here. This is the final arm and this is the initial arm. OA is the initial arm and OB is the final arm. So in how many ways can we reach OB? So we can reach OB directly like this, rotating OA in an anticlockwise direction and coinciding it with OB. Or we can also reach OB in this way. We can take one complete rotation and then again spiral around and reach OB position, correct? So let's say that in the initial step, what we are doing is we are going directly from OA to OB. So that is the first angle. But when we are taking a complete rotation and reaching the final position OB again, we are basically we are getting same angles, but now the rotation is different. So the measurement of the angle is different. Okay. So the initial arm and the final arm coincide. Initial and final arm coincide, but the rotations are different. Therefore, the angles are different. This is a short form for angle. Therefore, the angles are different. Okay, fine. Okay. So let us have a look at the definition. So coterminal angles are nothing but directed angles of different amount of rotation. So the amount of rotation is different, but the same position, but it has the same position of initial rays and terminal rays. Initial rays and terminal rays. Okay. So that was again quadrantal angles and coterminal angles. So let us revise. What were quadrantal angles? Those were the angles in the standard position. That is, the vertex should be at the origin and the initial arm should be on the positive x-axis. And the final arm can be where? It can be anywhere on the x-axis, positive or negative, and or anywhere on the y-axis, positive or negative. Then we have coterminal angles. What are coterminal angles? The angles which have this different amount of rotation. The amount of rotation is different, but the positions of the initial and final arm coincide. Okay, chalo. Now, measuring an angle. So, whenever we do some measurement, we require a system of measurement. So, while measuring angles, we have two systems of measurement, which are those: a sexagesimal system or a circular system. In the sexagesimal system, the unit of measurement of the angle is degree, and in a circular system, the unit of measurement of the angle is radian. Now, what are these two systems? Let us have a look at them in the detail. So, sexagesimal system is a system in which one complete rotation is divided into 360 equal parts. One complete rotation is divided into 360 equal parts, and that single part, which is the 1 by 360th part of complete rotation, it's called as 1 degree. It is called as 1 degree. So what is 1 degree? It is 1 by 360th part of one complete rotation. Now, if we divide that degree into more 60 parts, then 1 by 60th part of that degree is called as minute. It is called as 1 minute. So 60 minutes gives us 1 degree. Further, if we divide that minute into another 60 parts, then we get a single part which is called as a second. So 60 seconds give us a minute. So this is what we have written over here. 1 degree is nothing but 60 minutes, and 1 minute is nothing but 60 seconds, and 360 degrees give us one complete rotation. Fine. So when we divide the complete rotation into 360 equal parts, we get 1 degree. When we divide that degree into 60 equal parts, we get a minute. When we divide the minute into 60 equal parts, we get second. Fine. So 1 degree is 16 minutes and 1 minute is 60. 1 degree is 60 minutes and 1 minute is 60 seconds. Fine. So that was about sexagesimal system. Now we have a circular system, which is another popular system for measuring angles used majorly in trigonometry. So we have a circular system in which the unit of angle measurement is radian. And how do we denote it? 1 superscript c. 1 superscript c. How did we denote degree? So if we have 1 degree, then it is denoted by 1 superscript 0. Okay. How do we denote radian? 1 superscript c. Fine. Now, how do we define 1 radian? For that, what do we require? We require a circle. We require a circle. So we have a circle over here with a radius r. Now what we are doing, we are creating a sector by using this circle and the radius. So this is the sector which we have created. This is the sector which we have created by using the circle and radius. Okay. Now the length of that sector which we have created is equal to the radius of the circle. Okay. Now this sector, as we can see, is subtending an angle. It is subtending an angle, this angle. It is subtending this angle. Okay, this angle it is subtending where? At the center of the circle. Okay. Now, the definition of 1 radian goes this way. It is the angle subtended where? At the center of the circle. By whom? By an arc. So this sector created, the length of this sector is called as arc on the circumference of the circle. So this arc basically subtends an angle at the center of the circle, and if the length of this arc is equal to the length of the radius, if the length of this arc is equal to the length of the radius, then the angle subtended by that arc at the center of the circle is called as 1 radian. So what is 1 radian? It is the angle subtended at the center of the circle by an arc whose length is equal to radius of the circle. Fine. And how do we denote it? 1 superscript c. Now, in this definition of radian, it is important to note that it is independent of the radius of the circle. It is independent of the radius of the circle. So whatever the radius be, 1 meter, 2 meter, 3 centimeter, 1 millimeter, if the length of the arc is equal to the radius of the circle, then the angle subtended by that arc on the center of the circle is called as, will always be 1 radian. Okay. if there are two systems of measuring the same quantity, obviously there are conversions available to go from one system to another system. In the similar way, there is a conversion available for going from radian to degree and degree to radian. Okay, and how do we go from one system to another system? Let us see. So 180 degree is equal to pi radian. 180 degree is equal to pi radian. Okay, how do we do that? Basically, we have to compare the circumference of the circle and the angle subtended by the arc at the center of the circle. So basically, there's a theorem that the angle subtended by the arc at the center of the circle is proportional to the length of the arc. So as you increase the length of the arc, the angle subtended at the center is going to increase. And by using the relation that for the whole circumference of the circle, that means the length of the arc becomes equal to circumference of the circle, the angle subtended at the center becomes 2 pi. Okay, from that we get this answer that 180 degree is equal to pi radians. So how much is 1 radian? 1 radian is equal to 180 degree by pi, and 1 degree becomes pi by 180 radians. So from that, here are some angles for which I have calculated the degree and the radian convergence. So for 90 degree angle, the radian measurement that we get is pi by 2 radians, and for 360 degree it is 360 into pi by 180, which is 2 pi radians. So over here on the right hand side, I have the general formula for conversion from degree to radian and radian to degree. So if we have theta degrees, then in radian it becomes theta into pi by 180 radians, and if we have theta radians, in degrees it becomes theta into 180 by pi. Okay, so these are the important formulas that you need to remember for degree to radian conversion and radian to degree conversion. Okay, fine. Now, arc length and area of a sector. Okay, so this is the sector as I discussed earlier. Okay, and the length on the circumference of the circle corresponding to this sector is called as arc. Okay, fine. Let the area of this sector be A. Okay, so and let the area of the sector be A, and the length of this arc, let me just highlight it, this is the length, yeah, and this length of the arc be S. So we have the area of the sector as A and the length of the arc as S. Now how do we calculate this area A of the sector and length S of the arc? Let us have a look. So for that, we need to remember, while calculating the area, we need to remember that the area A of the sector is proportional to the central angle theta if the central angle theta is in radian. So remember that as the angle at the center increases, subtended at the center increases, the area of the sector goes on increasing because they are in direct proportion. Okay, but the only thing that you need to remember is that the angle should be measured in radians, not in degrees. The angle should be measured in radians and not in degrees. Okay, chalo. So we have direct proportion, therefore theta is proportional to A, therefore theta upon 2 pi becomes equal to A upon area of the circle. Now 2 pi is the angle when subtended at the center. The total area of the circle is available to us. So when we subtend an angle of 2 pi at the center, the total area of the circle becomes available to us. Therefore we get theta upon 2 pi is equal to A upon area of the circle. Okay, fine. Let's have a look over here. See, we start from over here. And we reach again here, right? So this is the complete rotation where the total area of the circle is available, and this angle is nothing but how much angle? Total angle, which is 2 pi degrees, which is equal to 2 pi radians, which is equal to 360 degrees. So therefore we have theta upon 2 pi is equal to A upon area of circle. Now we know area of circle is pi r square, so pi and pi gets cancelled over here, and therefore we get theta area is equal to half into r square into theta, where r is the radius of the circle. So area of the sector is half into r square theta. This is the relation that you need to remember. A is equal to area of the sector is equal to half into r square into theta. Similarly, arc length S is also proportional to the central angle, but the angle should be measured in radians. Okay, arc length S is proportional to central angle, but the central angle should be measured in radians. Again, by using the direct proportion relation, we have theta upon 2 pi is equal to S upon 2 pi r. 2 pi gets cancelled, therefore we have S is equal to r theta. Okay, so the final relations that you need to remember are the area A of the sector, when the arc subtends an angle theta at the center is half into r square into theta, and the length of the arc S is nothing but r theta. The only thing that you need to remember over here is theta is measured in radians. Theta is measured in radians. Okay, fine. So that was all about angle and its measurements, where we saw the basics of angle, the types of angle, then we saw about measurement of angles, how we convert from theta to radians and radians to theta, where we saw this relation theta, if we have in degrees, I'll show the relation there. Yeah, where we have the relation theta in degrees is nothing but theta into pi by 180 radians, and theta radian is nothing but theta into 180 by pi degrees. Okay, fine. And finally we saw the area and sector lengths, the length of the arc, the area of the sector and the length of the arc formulae. Okay, so that was all about angle and its measurement. In the next video, I'll try to include a few questions from the textbook, and after that we'll start with the next topic. So thank you, have a great day.